Okay, so what I'm going to do today is go over the three levels of pain control and the three models by which we kind of base how we control pain with therapeutic modalities. Now, from the standpoint of right now, and I put this in for the online, we're going to get more detailed in this in lecture after the first test. But since we're going to be moving on with modalities, I want you to have an awareness as to why you're going to be doing a lot of these things for pain reduction. So hopefully, as was outlined, you've at least reviewed the material on the 2 pages in the text. What I'm going to do here is just kind of give a little bit of an explanation as to how each of these levels of pain control work. You're going to have a little in-class activity to do that you'll kind of explore this topic just a little bit further in looking at how modalities are applied for this. Again, from the standpoint of the first exam, this material will all be covered more in depth for the second exam to be given in lecture. But again, you're still going to have to learn it, so having at least some information now should then hopefully help you a little bit more once we get into it a little more in depth. Okay, so I have these illustrations talking about that kind of illustrate how these different levels of pain control work. So we're starting at level 1 here, and your level 1, or what they also call your ascending pain control, is based on one of the earliest yet still utilized theories of pain control known as the gait control theory. So think of something like this, just to give yourself an example. If somebody in class was to tap you on the shoulder to get your attention, okay, obviously your brain is going to sense from the sensory fibers of getting tapped on the shoulder that someone had done that. Versus if someone were to punch you in the shoulder, okay, punching you in the shoulder would stimulate pain fibers and that's going to, again, pain we all know is an unpleasant experience. So what the gait control theory does is talks about how you can basically utilize your sensory fibers, your non-pain sensing sensory fibers, to sort of interfere with what you get from your pain fibers. So let's go back to the punching in the arm idea. If someone were to punch you in the arm or punch you in the shoulder, what's the first thing you typically think to do? Okay, think about that for a second. Okay, what you should be thinking is what you usually think to do is to either grab the area or sort of rub it. That's sort of very basic gait control. What you're trying to do, the reason why when you get punched in the arm you go to rub your arm, is because you're trying to interfere. It's your body's way, that rubbing of your shoulder. The idea is you stimulate your other sensory fibers in order to interfere with the pain signals that are coming from what you just experienced. That's kind of how gait control works. So, and we're going to talk about the different nerve fibers when we get to this in class. I'm not so concerned that you understand it now. I just want you to know the basic concept. So if you look at this little kind of guide that I have on here, you see the brain, you see the spinal pathways. The SG stands for substantia gelatinosa. Right? That's a part of the dorsal horn of your spinal cord that kind of leads to the gait. Okay, the gait is the T cell or the transmission cell. So the concept here is if you have a pain stimulus, so that pain stimulus will get transmitted to the brain and it'll get interpreted as pain. What you look to do with the gait control theory is interfere with those pain fibers by stimulating other non-painful sensory fibers, and by doing that you, as they say, quote unquote, close the gate to pain. So in other words, as the information coming in from the non-painful sensory fibers comes in, interacts with the substantia gelatinosa and the T cell, which again is what's considered the gate, that will prevent those signals, and the picture kind of illustrates that happening. That will prevent those signals from getting transmitted to the brain and being interpreted as pain. Now, the one thing about this theory was that they kind of felt it was incomplete, and there were reasons for thinking that. So what they discovered, and I have this up here with the updated in Keflin, And enkephalin is kind of a morphine-like substance inside the body, so your body has all your own natural chemical painkillers, if you will. So your body sort of has its own pharmacy of pain-killing substances. And what they found is that in the substantia gelatinosa, there's these enkephalin interneurons that are basically stimulated by these non-painful sensory fibers. So in addition to having the non-painful sensory fibers being stimulated, they also allow for this chemical enkephalin to be released, which will further inhibit the pain fiber. It doesn't so much change the theory per se, it just basically added in another substance that kind of interacts with this. Okay, so that takes us to level 2. Now, again, keeping this, just looking at it from a simple level, if you noticed on the last picture, okay, you had a block happening at the spinal cord preventing transmission to the higher brain areas, okay? Now what you have is actually the brain sending down transmissions causing the release of substances and then blocking it still blocking it at the spinal cord level, but having it that it's information sent down from the brain. Okay, so level 1 is ascending pain control. You're preventing that information from going up to the brain. Level 2 is descending. So now what you're doing is you're applying a modality that is going to trigger the release and stimulate areas in the brain to send things down, again, descending, to the spinal cord and block pain that way. Now, interestingly enough, and depending upon what your experiences have been in seeing things, the way you trigger this, and this may sound counterintuitive, is that you're actually applying a modality that is a noxious stimulus, meaning that the modality itself actually induces a level of discomfort or pain, okay? And maybe some of you even in class, if you've had some sort of rehabilitation done, maybe you've had something done where there was a slight level of discomfort experienced, and it could have been a situation where it was a modality that was inducing pain control via this descending inhibitory control. So the way this basically works, again, say you have somebody that has pain for whatever reason, you would apply the modality. What the modality would do is trigger these higher areas of the brain, and I have illustrated here the particular structures that get triggered. The raphe nucleus and the periaqueductal gray matter are the two areas that kind of modify pain in this instance. They will cause the release of two chemicals, one being enkephalin, which we talked about already, and we know that how that works at the dorsal horn of the spinal cord. The other one being serotonin. Those will then go down to the spinal cord and block pain in that fashion. Okay? So again, and this is induced by a noxious stimuli. All right? And I don't want to get into particular modalities in this talk that do that, because part of what you're going to do in class is look at, well, what modalities, and use your books and your notes and everything else to talk about what modalities do this. Okay? So this is the descending inhibitory control again. So think about ascending versus descending and how that works again. And for now, just have a basic awareness of the structures involved and how the chemicals work. And then here's your level 3. Level 3, as you read in your book, is also known as beta endorphin mediated pain. Now, looking at this picture, what do you notice about how pain gets blocked? So take a look at this for a second and just think to yourself how pain is getting blocked here. Now, what you should be thinking in looking at this is there's nothing coming back down directly to the spinal cord, unlike the previous two illustrations. Okay? Everything is happening in the higher areas of the brain, by the release of a substance called beta endorphin. Okay, your beta endorphins are another substance that your body will naturally produce to limit pain. Again, this mechanism is going to be stimulated again by actually using modalities that will stimulate pain fibers. Okay, so what we're actually going to be doing here is, again, applying a modality that will cause some level of discomfort for the patient, but in the end will have, and particularly in this instance, a much longer after effect. Okay, so to compare to, for instance, of the gate control theory, you apply a modality for the gate control theory. Once that modality is removed, for the most part, pain's going to come back. Okay, there's maybe one exception, and that one exception is even debated whether it really is involved in gate control. And I'll talk about that in class a little bit when we get to it. But when you remove the modality, when you're applying the gate control theory, the pain usually comes back fairly quickly. Versus with this model, you have a more prolonged relief from pain. So when you remove the modality, you'll actually get a few hours of pain relief after applying it, because the beta endorphins have a longer half-life and will provide a longer term pain relief mechanism than you would with the other two. Okay, so even though, again, this may induce a slight amount of discomfort for the patient when it's being applied, the long-term effects are more beneficial. So again, the pain fibers will stimulate the higher areas of the brain. In this instance, when applied appropriately and stimulating the right pain fibers, you'll get the release of beta endorphins from the pituitary gland. Okay, so we all remember the pituitary gland in class, and we talked about a lot of the things that the pituitary gland does. It also stimulates the release, again, of this other kind of natural painkiller that your body produces. So, and again, the benefit to the endorphin release is that you will get a slightly longer amount of pain relief. The half-life, or when half of it is reduced, is about 4 hours. So you get quite a long time of pain relief with the release of beta endorphins. All right. So that kind of concludes this basic look at your 3 levels. And this will be posted up. If you want to listen to this again, feel free to, if you didn't get every single thing down. But I think for the most part, it should give you a basic idea. So now your in-class assignment that you're going to do in lab right now is you're going to look at what modalities actually stimulate each one of these 3 levels of pain control. And there are some specific ones that even in the reading that I gave you, your book mentions. So you'll write those down and you'll have a brief discussion in class.